Alrighty, guys. Let's take a look at this problem real quick. So who wants to read it? Go ahead, Daniel.
The table at the right shows Cameron's fitness program. He knows that after he warms up to maintain a constant running speed of 8 feet per second. Graph the data and find the rate of change between several plotted points. What do you notice?
Okay, so they've already given us all the information, right? They've already given us all this information. They filled out the table for us and everything. So they've got a table, they give us the amount of time, they give us the amount of feet that Cameron is running, and all we gotta do is we gotta graph it. So that's the first thing we're gonna do is we're gonna graph it. So we'll come down over here, all right? We get this record thing in there, but that's okay. So we go like this, and this is my y-axis, right? That's my y-axis. And this one right over here, what axis is this? That's my x. And guys, just so that you know, in your table, the seconds is the x-axis and the distance is the y-axis. So this bottom one right here, right? This bottom one right here becomes, this is time in seconds. So this is time in seconds. And this over here, the y-axis, is distance in feet, okay? So now what we've got to do is we're going to take a look at our table, and what we're going to do is we are going to figure out, okay, we want to put our scale together. So, because we have a fair amount of data points to put in, we want to kind of space it out so that we have plenty of room so we can sort of see what we're doing here. All right, so we know 0, 0 is a point because they tell us 0, 0. So we know this is 0 here and this is 0 right here, 0 seconds and 0 feet. So why don't we do this? Every 4 boxes on the x-axis, every 4, we'll say that that's going to be 2 seconds. So here's 2, right? Here's 4. Here's 6. And here is 8. All right? And we'll do the same thing on the y-axis for the distance, except every 4, what we'll do is we'll go up and see 1, 2, 3, 4. We'll say that is, Aiden, every 16 feet, okay? All right, so that we have plenty of room on this graph so we can see stuff. So that's 16, go up another 1, 2, 3, 4. That'll be 32. Go up another 4, 1, 2, 3, 4. That's 48. And 1, 2, 3, 4. We'll stop up here at 64. All right, and now what we've got to do is we have to plot, okay? We have to plot our points. Okay, so let's plot our points. So someone give me a coordinates off of the table. Go ahead, Dino, give me one.
216.
216, right? So we go at 2. We put a point here at 216. So that's our first point, 216. What's another coordinate pair? Dorian, what else we got? Can't hear you. 432. So we put a point here at 432. What's another, Daniel?
648.
648. Right there. 6. Go up 6 from the x-axis. Go over here to 48. Put a point right there. What's that last one? Shane, what do you got? 8. So we go up 8. And we go over here to 64. Now, do we have another point we can put in? Destiny, do we have another point we can put in based on the table? Look at the table. 0, 0. Nice. All right, so we go 0, 0. All right, and now what we can do is we can connect these points. So we connect these points. What do you notice about that line? Tara, what do you notice about that line? It's straight. So we got a straight line here. So now what we want to do, when you take a look at the handouts that we have, we want to find the rate of change. We want to find the change in the distance over the change in time. So let's pick these 2 points right here, this point right here and this point. I want to find out the change in distance over the change in time between this point, 864, and this point, 648. So it's almost like I'm making this little triangle here. All right? Now, how do I find this distance from here down to here? What do I got to do to find this distance from here? Mr. Kearns? Okay, but how could I find it if I notice that where I'm crossing on the y-axis, and this tells me where I'm crossing on the y-axis. How can I find this length right here? Okay, so how do I do that? Okay, so I go 64 minus 48, right? 64 minus, and how do I find this distance between this point right here and this point right here? How do I find that distance right there? Dorian? Yeah, so I go 8 minus 6. What's 64 minus 48, Mr. Katie?
64 minus 48. Is 16.
Okay, so that's 16, right? And that's 64. This was all in feet, so it's 16 feet over, what's 8 minus 6, Mr. Katie? 2. And that's over seconds, so 2 seconds. What does that reduce down to? What does 16 over 2 reduce down to? Shane? All right, so I get 8 feet over 1 second. Okay, tell you what, let's take this point. I want to find the rate of change between this point right here and this point right here, right? So if you think about it, right, I'm kind of making this looks like this, and this looks like this. How do I find this distance, Daniel? How do I get this distance right here? What's the coordinate of that point? Where am I intersecting the y-axis?
48.
48, okay. So I want to get the distance between this point, which is 6 and 48, and this point, which is 2 and 16. So this intersects the y-axis there, and this, if I continue this all the way, where does that intersect it at? Someone say, where is it intersected here? So how do I find this distance right here between this point and this point? Subtract 48 minus 16. How do I find this length right here, Daniel, between this point and this point on the x-axis?
6, no, yeah,
Yeah?
6 minus 2.
6 minus 2. So what's 48 minus 16? Who's got 48 minus 16? Alex?
32.
32. What's 6 minus 2?
4.
4. Okay. What is 32 over 4? Simplify down to?
Divided by 4, so it's 8 over 1.
8 over 1. All right, so I get 8 feet all over 1 second. Okay, let's take these 2 points right here. I want to take this point right here, right? What's the coordinates of this point right here? Okay, this point and this point. I want to find the rate of change of this line right here. So I'm making this like little... Okay, so I want to find this length right here. How do I find that length right there? Where does this intersect on my y? It's at 32. This one's at 16. So how do I find this length right here? I've got my coordinates are 4 and 32, and this one right here is 2 and 16. How do I find this length right here? What do I got to do? Jordan, what do I got to do to find this length right here?
Well, it says 6 and 48, so 46, is that 16?
This is 48 minus 16. This is,
Where you wrote down the 16,
yeah,
on the formula on the side, that's 16?
this right here is 16.
No, go up, like, go up one more. Is that 6?
That's 6 and 48, right? That's this point right here, Jordan, look. Look on your graph, 6 and 48, right? 6 on the x, 48 on the y, that's 6 and 48. This one right here is 4 and 32. This one right here was 2 and 16. So how do I get this point right here? How do I get this length right here? Daniel?
So you have to subtract 16 from 32.
Yeah, so I go 32 minus 16. And how do I get this length right here, Shane? What do I gotta do to get this one?
You subtract, 4 by 2.
4 by 2, right? 32 minus 16 is 16. 4 minus 2 is 2. 16 over 2, what does that reduce down to? 8 over 1, 8 feet. Again, over 1 second. What do you notice about all these rates of change? What do you notice about all these rates of change? Mr. Katie?
They're all 8 feet.
They're all 8 feet over 1. They're all the same, right? That's a constant rate of change. Another name for constant rate of change is slope. This is what slope's all about. Slope is, if you have a constant rate of change, that's called slope. And that's how we go about finding the slope of this line. That's exactly what you've done, right? We've graphed it. You've got the slope of the line.